Over the past few decades, technology has been applied to virtually every industry. The construction and civil engineering industries are no exception, with technology being utilized in every step of the construction process. However, many challenges still remain. Every construction project inevitably generates large amounts of rubble and debris. Removing that rubble has both financial and environmental costs. The heavy vehicles used for the rubble removal consume large amounts of fossil fuels, adding to the release of greenhouse gases, pollutants and other dangerous byproducts that are toxic to the environment. As an example, the renovation of a 100 square meter apartment will generate waste of around 15 tons. In addition, around 12 tons of new building material must be transported again to the construction site. This leads to the question, why isn't this discarded material reused for building purposes right on site? Reuse will drastically reduce the waste as well as the new material required and therefore reduce most or even all transportation needs. Another challenge in the construction industry is the accessibility of certain specialized construction sites. For example, leakage at a nuclear reactor could make the site lethal for human workers. Unstable mining tunnels, military activities, and other hard-to-reach areas could be too dangerous for the health and lives of human construction workers. The Surface Former 1 is aimed at addressing these challenges. The Surface Former 1 is a robotic system used for the modification, construction, and reconstruction of partial or entire building structures. This fully automated system is able to alter or create walls, floors, ceilings and facades with high precision according to the individual specifications of the customer. The system will do this by performing the following tasks. First, it will scan the room with a laser. It will also scan all the hidden structures with the use of an electromagnetic wave transmitter positioned on the other side of the wall. In this way, a highly accurate 3D model of the existing space will be created. This model will be available to the user through specialized software. The 3D model will also be able to indicate any possible issues with the physical space, such as uneven surfaces, suspect support structures and hidden plumbing or wiring. The user can now manipulate this 3D model to create the desired space. The user can remove or add structures, level surfaces, add or close opening, create holes and channels for new wires and pipes, or otherwise customize the space with a multitude of features. The software can calculate the amount of materials needed and the amount of materials that will be removed. It will also calculate the amount of removed material that can be reutilized by the 3D printing system. The system will, in effect, calculate the most cost-effective way of completing the construction job. When the user is satisfied with the final 3D model of the desired space, the robot is put to work. With its unique milling and 3D printing technology, as well as its state-of-the-art multi-directional movement, the Surface Former 1 will transform the physical space into the desired space with very little to none human interaction. To modify walls and ceilings, the robot is able to climb walls and even hang upside down from ceilings using a drill and lock system on each leg. The milling waste is automatically collected in the particle unit. This unit then remanufactures the waste particles, mixes it with the binder material and produces the substance used for 3D printing. In this way, the system reuses most of the waste created on site. The Surface Former 1 is more accurate, cost-effective and safer for humans. It is better for the environment as it drastically reduces the need for heavy industrial construction vehicles and machines. The system reuses milling waste for 3D printing. It can operate individually or as swarms of robots, and it is scalable in size. The Surface Former 1 uses state-of-the-art technology. This patented system combines technology, mechanical engineering and civil engineering in a way that has not been done before.